Just to follow up with another paper which phrases this as a question, it says, can El Nino Southern Oscillation events, ENSO events, modulate intraseasonal oscillations of Indian summer monsoon? They use a different approach and they use two different methods to look at self-organizing maps to make their conclusions. So let's read their abstract, and I'm not even going to show any figures, and I will uh, read the last paragraph of their discussion and conclusion. Just to add to the previous broadcast, predictions of interannual variability of Indian summer monsoon rainfall is limited by internal dynamics, and the monsoon intraseasonal oscillations seem to be at the heart of producing internal IAV of the ISM. So there is internal variability of the monsoon, which means even without any El Nino, monsoon can look different from year to year. So you can have intraannual variability that is just internally generated, and then there are intraseasonal variability within each season, and obviously there is intraannual variability of the intraseasonal oscillations as well, or monsoon intraseasonal oscillations and mesos. Nonlinear systems obviously will have a lot of internal variability, but they can still be modulated by external forcings like El Nino in this case, or La Nina. If one could find an identifiable way through which these mesos are modulated by slowly varying external forcings such as El Nino Southern Oscillation, the uncertainty in the predictions of IAV could be reduced, leading to improvement of seasonal predictions. Such efforts so far have been inconclusive. Okay, so when you have a full model that is doing El Nino as well as monsoon, obviously it will internally do monsoon response to El Nino and intraseasonal variability and mesos and interannual variability of the mesos as well as El Nino modulation of those and so on. But understanding these is critical, especially now because we are often separating the time scales of El Nino prediction from meso prediction, because you can do them as a post-processing like MJOs and mesos. Especially now with AI, you can really separate them, and predicting monsoon at intraseasonal timescales is going to be very critical for many sectors like agriculture, water, energy, even health, and so on, right? So in this study, the modulation of mesos by ENSO is assessed by using a nonlinear pattern recognition technique known as the self-organizing map. The SOM technique is efficient in handling the nonlinearity, event-to-event variability of the mesos, and capable of identifying various shades of meso from large-scale dynamical and thermodynamical indices without providing information on rainfall. So in the previous paper, we talked about the changes in the background conditions that seem to be important for meso response for evolving, decaying, and during El Nino events. But background conditions themselves can produce internal variability, because without any external conditions, monsoon circulation has interannual variability. This is what we call internal variability, right? Here they are talking about, separating the ENSO modulation of the internal variability as well, if you understand what I mean. Okay, so it is shown that particular meso phases are preferred during ENSO years. That is, the canonical break phase is preferred more in the El Nino years, and the typical active phase is preferred during La Nina years. This is intuitively consistent with deficit monsoons during El Nino and surplus monsoons during La Nina, because monsoon again has to work through active break periods as an intrinsic time scale. Interestingly, if the SOM clustering, self-organizing map clustering, is done by removing the ENSO effect on the seasonal mean, the preference for the break node remains relatively unchanged, whereas the preference reduces or vanishes for the active node. So this is a detail that you have to understand. Background states are somehow being modulated by El Nino, such that the break node is not changing much, but based on the ENSO phase, but the active node is. The results indicate that El Nino break relationship is almost independent of ENSO monsoon relationship on seasonal scale, whereas the La Nina active association seems to be interwoven with the seasonal relationship. Okay, so carefully understand it, because we are talking about uh, El Nino impact and La Nina impact on seasonal cycle of the monsoon, seasonal total rainfall, but that is also associated with internally with active and break periods. But it turns out that the seasonal teleconnection of El Nino with the monsoon and the La Nina with the monsoon are, uh, positive, deficient rain and surplus rain, but they are differently manifest in break and active period. So La Nina active association is uh, related to the seasonal relationship, so that more rain during La Nina comes with a response in active phases, whereas the reduced rainfall during El Nino is not so much coming to the through the break relationship, which can mean break periods have higher internal variability and are not so closely related to El Nino. Okay, so go and read the paper, but I'll jump to the end. The study is unique in the sense that it provides clear evidence on the association between ENSO and MESO, especially on the influence of ENSO on the residence time of MESO, how long it lasts in its transition from the tropics into the monsoon domain. You et al. Also indicate You et al. Also indicated, that it should be indicated, but they say indicated that ENSO can influence, or maybe indicted, that ENSO can influence particular phases of ISO. However, the ISO they referred two was the Madden-Julian oscillation in the boreal summer, which has northward as well as eastward propagating components. So now we are getting into the other debate about whether MESO is separate from the boreal summer ISOs, or MJOs, or other MJO only occurs during April to October season, and the detoured MJOs northward can be called MESOs. The whole debate I've discussed elsewhere. Here our focus is on the MESO, which has prominent northward propagation. Also, the technique they used, which you et al. Also used, exhibited difficulties when trained over a reduced domain. Hence, they could not produce results consistent with the ones they got when training was done over a bigger domain. When you use statistical approaches like self-organizing maps and empirical orthogonal functions, there is a dependence on the domain you select. And that's always worrisome if you cannot reproduce the results that you get in a smaller domain with a bigger domain. So you have to be very careful about, because those are statistical interpretations, then you have to go back and connect them to actual dynamic mechanisms. If you cannot do that, then obviously your statistical results may just be, artifacts, right? So an important advantage of the present study is that the SOM technique could isolate the various shades of MESO and its relationship with ENSO. So internal variability of MESO is somehow captured simply by using large-scale dynamical thermodynamical indices alone. The results have great implications for improving the predictability of the parts of IAV, interannual variability, that are controlled by nonlinear and chaotic MESOs. Anytime you have a variability that has, anytime you have a mode, let's say like MESO, which has high internal variability, you can call it nonlinear and chaotic. Okay, so I'm not being very detailed at all, but I hope you get the point that there is a relation between El Nino, La Nina, and monsoon, but also they are at seasonal time scale and intra-seasonal time scale. During an El Nino, this relationship seems to be mostly on the seasonal time scale because the break node shows no much modulation from El Nino, as during La Nina, active phases as well as seasonal totals show modulation. I hope I said it right, but you must go and confirm for yourself. Okay, but just get the point that there are things to worry about. And predictability means once you have a model that is doing the whole thing, you want to see whether it is reaching the theoretical prediction potential. If not, why not? Okay, I will leave it there.